Hey guys, welcome. This is 8.6, double angle and half angle formulas. So more formulas to put on top of the other formulas we know already. So we want to derive formulas for sine 2 theta and cosine 2 theta. So we will first start with sine 2 theta, and we are going to manipulate the sum formula for sine. And the way we do that is by an equality property. We will let alpha be equal to beta, and we will let alpha and beta both be equivalent to beta. But first, let's start with the actual sum formula for sine. So that's where we'll go first. We'll start with that. Okay. So we know that sine alpha plus beta can expand to sine alpha cosine beta plus cosine alpha sine beta. Okay, but now we bring in this equality property. So we bring this equality property and we will take theta and plug it in for alpha and beta everywhere, okay? All right, so this becomes sine theta plus theta equal to sine theta times cosine theta plus cosine theta sine theta. Clean it up. Sine of theta plus theta becomes sine of 2 theta. And since these terms are exactly the same, we get our formula for sine 2 theta. We get sine 2 theta is equal to 2 sine theta cosine theta. There it is. We now have a formula for sine of 2 theta. This is a double angle formula for sine. Remember that. It'll haunt you in Cal 1, and it will definitely haunt you in pre-Cal. Cal 2. Boom. You're already in pre-Cal. It's already haunting enough. Okay. So we're going to do the same for cosine. We want a double angle formula for cosine. So we will manipulate the sum formula for cosine with the same equality property. So let's start with cosine. So cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Okay, now bring in the thetas, and we'll have cosine theta plus theta equal to cosine theta times cosine theta minus sine theta times sine theta. Okay? Well then, this becomes cosine 2 theta equal to cosine times cosine is cosine squared theta minus sine times sine, sine squared theta. And we have it. One formula for cosine 2 theta. We can make 2 more double angle formulas for cosine, which are helpful. I mean, out of all of them, this is probably the most popular one. But say we had to make more. This means that this will be number 1. Now, if we want to make 2, I will take cosine 2 theta equal to, and what I'm going to do next is change sine squared. And we already know an identity for sine squared. Sine squared is the same as 1 minus cosine squared theta. So that's what's going to happen here. You're going to get cosine squared theta minus, parentheses, 1 minus cosine squared theta, which becomes cosine squared theta minus 1 plus cosine squared theta, which means we get our second formula. Cosine 2 theta equals 2 cosine squared theta minus 1. There we go. Now let's go for the third one. So we'll start back at the original. Cosine 2 theta equal to cosine squared theta minus sine squared theta. And now I'm going to change cosine squared theta into its identity of 1 minus sine squared theta. That's where we'll go. So cosine 2 theta is equal to 1 minus sine squared theta minus sine squared theta. Clean it up, and we get cosine 2 theta equal to 1 minus 2 sine squared theta. There it is. Formula number 3 for cosine squared theta. There we go. So 3 formulas for cosine 2 theta, only 1 formula for sine 2 theta. That's 4 more formulas on top of the 6 formulas we learned last class. That's 10 formulas. Ugh. Okay. There might be more, right? Maybe. Okay. All right. So let's go ahead and find the exact values of our given trig expressions using double angles. So we are given sine of theta is equal to the square root of 6 over 3. And theta is stuck between pi and pi over 2. So the first thing we want to do, draw our quadrant. And this will relate to both problems. So let's draw our quadrant. And here is pi over 2, and here is pi. Which means if we're stuck between pi over 2 and pi, which means we must be in the second quadrant. Here's theta. And then if it's sine of square root 6 over 3, sine puts opposite over hypotenuse. So that means that this side is the square root of 6. The hypotenuse is 3. And by Pythagorean theorem, you'll get 9 minus 6, which is 3. So you'll get the square root of 3. But it will be negative because it's in the second quadrant. Okay. Now let's solve for sine of 2 theta. And we can expand that by the formula we just learned. Sine of 2 theta becomes 2 sine theta cosine theta. Well, reference our triangle, and we'll find sine theta and cosine theta, or sine theta is given above. So that's given already. So this becomes 2 times the square root of 6 over 3 times cosine, which is negative square root of 3 over 3. Negative square root of 3 over 3. Okay. Clean it up, and we will get what I'm going to have, negative 2 square root 18 over 9. Now, does the square root of 18 break down? Yeah. Square root of 18 becomes square root 9 square root 2. Square root of 9 becomes 3. So what we are left with is negative 2 times 3 square root 2 over 9. And this 3 becomes a 1. Do a different color, right? That 3 becomes a 1. That 9 becomes a 3. And we're left with our final answer of negative 2 square root 2 over 3. There you go. All right, now let's do cosine 2 theta. And for cosine 2 theta, we can choose from 3 different formulas, right? I can do cosine squared minus sine squared. I can do 2 cosine squared minus 1. I can do 1 minus 2 sine squared theta, and we will get the exact same answer no matter what formula you choose. So like I said, I'm going to go with formula 1 because that's the most popular. But I can also show how another formula works. So let's go with formula 1 first. Cosine squared minus sine squared. So this becomes cosine squared theta minus sine squared theta. And from the above, we know that cosine is negative square root of 3 over 3, adjacent over hypotenuse. So that becomes negative square root 3 over 3 squared. Minus, and sine squared is the same from above, square root of 6 over 3 squared. Okay. Clean it up. That becomes 3/9 minus 6/9. Positive 3/9 minus 6/9. That gives me negative 3/9, which is negative 1/3. Okay, let's try it with a different formula. Let's say cosine 2 theta, and let's choose what? 1 minus 2 sine squared theta. We get 1 minus 2 times the square root of 6 over 3 squared. I'll get 1 minus 2 times 6 over 9. Then this will give me 1 minus 2 times, this becomes, what, 6 over 9, reduce that by 3, you get 2/3. Now, multiply that 2 in, and you get 1 minus 4/3. Bless me, thank you. And 1 minus 4/3, that becomes 3/3 minus 4/3, which is the same as negative 1/3. Same thing. No matter what formula you choose, you're going to get the same answer. Okay, so that's double angle. What are you doing, cat? All right. By the way, pig bandana, rocking it, enjoy it. Cat. All right. So still going. All right. Use double angles to establish identities. So we made a formula for sine 2 theta. We made a formula for tangent 2 theta. We made a formula for cosine 2 theta. I'm losing my mind. So now let's make a formula for tangent 2 theta using the sum formula for tangent. Now, if you remember that, I'll write it down. Tangent alpha plus beta is the same as tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. If you don't believe me, we can go back and check the notes. Sum and difference, check that out. And where was tangent? Somewhere right there. Tangent alpha plus beta, tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Which is what we have right there. Okay, now again, we're going to use the equality property. Alpha and beta are both equal to theta. So plug in theta for all of this. So we get tangent theta plus theta equal to tangent theta plus tangent theta over 1 minus tangent theta times tangent theta. And you get tangent 2 theta equal to 2 tangent theta over 1 minus tangent squared theta. There it is, a double angle formula for tangent. All right, what's that now? We're up to 11 formulas so far, right? That was the 5th formula we just created today. Whew, so many. Okay, so that is a double angle formula for tangent. What's next? Now, let's develop a formula for sine of 3 theta. Oh my goodness, so many formulas. Okay, so this is kind of like creating identities. And we are going to take a hint from the last couple of problems. To create these formulas, we had to use a sum formula. I mean, we could use a sum or difference formula, but I think the sum is easier to work with. So to make a sum formula for sine of 3 theta, we're going to take 3 theta and break it into 2 parts. And when we do that, sine of 3 theta will become sine of 2 theta plus theta. That's it. Because 2 theta plus theta is 3 theta. Okay, now expand this by the sum formula. This becomes sine of 2 theta times cosine theta plus cosine 2 theta sine of theta. And once again, I'll write it in. This used the sum formula for sine. So sine alpha plus beta, which was sine alpha cosine beta plus, not sine, cosine alpha sine beta. That's all we used. Okay. All right. So still going. Sine 2 theta. Well, we created a formula for that earlier. Sine 2 theta is 2 sine theta cosine theta. So that's what's going in here, parentheses. 2 sine theta cosine theta times the cosine theta that's there, plus, all right, next is putting a formula in for cosine 2 theta. Okay, so the one we're going to choose for this is, I'm just going to say we are assuming to put this all in terms of sine. That's all we want. We want this all in terms of sine. So for this cosine 2 theta formula, we're going to use the 1 minus 2 sine squared theta. That's what we're going to use. So that's what's going to go in here. 1 minus 2 sine squared theta times sine theta. Okay. And now simplify. This first becomes 2 sine theta cosine squared theta plus sine theta minus 2 sine cubed theta. This sine distributed to both terms there. Or the 1 and the 2 sine squared distributed to sine. However you want to see it. Okay. We're almost there. Almost, I say. Because now, again, I want this all in terms of sine. So we are using nothing but identities here. Identities and formulas. So cosine squared, we know, can become 1 minus sine squared theta. So that's what that's going to become. So you get 2 sine theta times 1 minus sine squared theta plus sine theta minus 2 sine cubed theta. All right, more cleanup. Here we get 2 sine theta minus 2 sine cubed theta plus sine theta minus 2 sine cubed theta. We have nothing but sine functions now. Woo! So our final step is putting it together. We get negative 4 sine cubed theta plus 3 sine theta. And this is now a formula for sine 3 theta. There you go. Save that. And also save this because I believe in your homework, you're going to be told to find an expression for sine 5 theta, find a formula for that. So you can break this into two angles. Guess what you're going to choose? Sine 2 theta plus 3 theta. That's why I say save this, because you're going to end up getting, when you expand this by the sum formula, you're going to end up getting a sine 3 theta, which you can make your work a lot easier, because now you know sine 3 theta is all of that. Okay? All of that. Okay. So that should help you out. Okay. So you have this formula for sine 2 theta, cosine 2 theta, tangent 2 theta, and now we have a formula for sine 3 theta. Yee-haw. Okay. Let's keep going. All right. Ooh, okay. Now we want to verify the identity. Tangent 3 theta is equal to 3 tangent theta minus tangent cube theta over 1 minus 3 tangent squared theta. Okay, so this is going to be a left side proof, because we can actually create a formula for tangent 3 theta. So that's what we're going to do here. It's going to be a proof by the left side. So tangent 3 theta, just like the last problem, we're going to take 3 theta and break it into two angles. So this becomes tangent 2 theta plus theta. How much room do I have? Just the whole page? Oh, yeah. All right, good. Okay. So we now will expand this by the sum formula for tangent. Remember that the sum formula for tangent is given as tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. All right, so that's the expansion, which means that this becomes tangent 2 theta plus tangent over 1 minus tangent 2 theta times tangent theta. Okay, so more expanding. So we created a formula for tangent 2 theta earlier. So tangent 2 theta is the same as two tangent theta over 1 minus tangent squared theta. So that's what we're going to use here. All right. And I got enough room to leave all those markups here. So that's what it's going to become. And I'll start over here. So we get that tangent 2 theta becomes parentheses 2 tangent theta over 1 minus tangent squared theta plus tangent theta over 1 minus, the same thing here, 2 tangent theta over 1 minus tangent squared theta times tangent theta. Just awful, huh? Okay, so what we're going to do next is we have to combine the numerator. So to combine the numerator, we're going to need a common denominator, which means I put tangent theta over 1 and multiply by that denominator you see there. 1 minus tangent squared theta over 1 minus tangent squared theta. All right, this ends up becoming 2 tangent theta plus, and what I'm going to do here is distribute this tangent with that 1 minus tangent squared theta. So that'll give me tangent theta minus tangent cube theta all over the same denominator of 1 minus tangent squared theta. So this is all happening in the numerator. Now to the denominator. All of this over what you see above. 1 minus, and now what's going to happen here is that this tangent and this tangent will multiply. Because I can even put this over 1, but when you multiply fractions, you multiply straight across. So this becomes 2 tangent squared theta over 1 minus tangent squared theta. All right, so the next step is to clean up the denominator, which means I need to put this 1 over 1 and get a common denominator of 1 minus tangent squared theta over 1 minus tangent squared theta. That's what we're doing here. Yeehaw, guys. Okay. So what you end up with is 3 tangent theta minus tangent cube theta over 1 minus tangent squared theta over, when you put these together, this will be negative tangent squared minus 2 tangent squared. So that becomes 1 minus 3 tangent squared theta over 1 minus tangent squared theta. Okay, almost there. You now have fraction over a fraction, so you will reciprocate. Multiply by the reciprocal. So this becomes 3 tangent theta minus tangent cube theta over 1 minus tangent squared theta times the reciprocal of everything in the denominator, 1 minus tangent squared theta over 1 minus 3 tangent squared theta. Okay, we've almost made it. Hey, look, I actually used all my room. Perfect, because we're done. This 1 minus tangent squared theta and that 1 minus tangent squared theta cancel. And we are left with 3 tangent theta minus tangent cube theta over 1 minus 3 tangent squared theta. Now, did we make the left side look like the right side? And I got 3 tangent theta minus tangent cube theta over 1 minus 3 tangent squared theta. That is good. Boom. All right. That makes you thirsty. Oof. Okay. Okay. So that's another formula. Who knows when you're ever going to need the formula for tangent 3 theta? Never. Okay. Let's keep going. Okay. So we come up with 3 more formulas. Oh my goodness. What is that? What are we at now? I don't even know. I knew we were at 10 and then 11. We're probably at 20 now. Who knows? That's a lot of formulas. But these ones are important. So by rearranging the double angle formulas we just created, we can obtain more formulas. So cosine 2 theta, which we found earlier, is equivalent to 1 minus 2 sine squared theta. Well, if I rearrange this and solve for sine, we come up with a new formula for sine squared. Oof. But we thought sine squared was 1 minus cosine squared. It is, but it's also this now. Only in terms of a double angle, okay? Okay. So if we rearrange that, we get a formula for sine squared, which is going to be equal to 1 minus cosine 2 theta over 2. Then, if we rearrange the second formula for cosine 2 theta, which was equal to 2 cosine squared theta minus 1, we get another new formula of cosine squared theta is 1 plus cosine 2 theta over 2. So now we have a formula for cosine squared in terms of double angles. And then next, if you put sine squared over cosine squared, you get tangent squared, which means if you put this formula over that formula, we end up getting 1 minus cosine 2 theta over 1 plus cosine 2 theta. So we have new formulas for sine squared, cosine squared, and tangent squared in the form of a double angle formula. So that's the only difference. Yes, cosine squared can still be 1 minus sine squared. But if we want to talk in double angles, then cosine squared will be 1 plus cosine 2 theta over 2. Okay, so you see how everything builds off of each other. And they just give us more formulas just for fun, you know? Why not give students 20 formulas to remember? Well, one thing that makes it simple is you know they're all built off of each other. Okay. All right. So now we want to establish an identity. This says, write an equivalent expression for cosine to the 4th theta that does not involve any powers of sine or cosine greater than 1. So we have to use the new formulas we just learned above to break this down into an expression that contains only exponents or powers of 1. So, here we go. How much room I got? Okay, I can write small on this one. All right. first thing we're going to do is take cosine to the 4th theta and break it apart. We're going to make this into cosine squared times cosine squared theta. Why did I break into that, you ask? Is because cosine squared has multiple formulas now. So why not break it into cosine squared? There would be no point to making this cosine cubed theta times cosine. That just wouldn't make any sense. So we don't want to do that. Okay, so we will now use the new cosine squared formula we learned above. And the reason I'm using this one is because what is the power of that cosine? That cosine is only to the 1st power. If I rewrote this, it would be cosine 2 theta, where this cosine is to the power of 1. And our goal is to break cosine to the 4th theta into smaller powers of 1, nothing larger. So we will be using this formula for cosine squared theta. 1 plus cosine 2 theta over 2. Which means that this is what it becomes. You get 1 plus cosine 2 theta over 2 times 1 plus cosine 2 theta over 2. Okay, looking good. So with fractions, you multiply straight across, right? You multiply straight across. So this would then become 1 plus cosine 2 theta times 1 plus cosine 2 theta all over 4. All over 4. Which means what we're going to do next is FOIL the numerator. So I should get 1 plus cosine 2 theta plus cosine 2 theta plus cosine squared 2 theta all over 4. All right, and to make our lives a little easier, I'm going to pull out the fraction of 1/4 and clean up the numerator a bit at the same time. So I'm going to have 1/4 out here, and inside my parentheses, I'll have 1 plus 2 cosine 2 theta plus cosine squared 2 theta. All right, guys, we're almost there. Almost there. This is perfect. That is perfect because it's the power of 1. This one ruins it all because it's to the power of 2. Okay, so this means the only thing we have to fix on this is this cosine squared 2 theta. So what I'm going to do with that is we're going to use the new formula we learned above, okay? So this is going to become that formula again. 1 plus, well, first let me rewrite it. So we're going to use this one again. Cosine squared theta is equal to 1 plus cosine 2 theta over 2. That's the new formula we learned. The only thing that's different here is that, well, this is for cosine squared theta. What I have over here is cosine squared 2 theta, okay? Cosine squared 2 theta. So what I'm going to do here is make a quick substitution. We are going to let 2 theta become, what's a good symbol? X. Everybody loves X. Sure. X gonna give it to you, okay? All right, which means that, with that being said, with our substitution, I now have cosine squared of, oh, so ugly, there we go. Cosine squared of X. So there's our substitution, which means if I follow the formula above, this becomes 1 plus cosine of 2x all over 2. But now, let's bring in what x is. So this becomes cosine squared of 2 theta, right? We bring our substitution back, which means that I get 1 plus cosine of 2 times 2 theta over 2. Which then, by cleaning it up, becomes cosine squared of 2 theta is now equivalent to 1 plus cosine 4 theta over 2. Save that process for future reference. You never know. Okay, so that was a little manipulating of the double angle formula we just learned for cosine squared. Okay, which means let's come back to this one, and we're going to plug in what we just found. Okay, time to write a little bit smaller. So now I have 1/4 times 1 plus 2 cosine 2 theta plus the new cosine squared 2 theta we just made, 1 plus cosine 4 theta over 2. I put that in its own little set of parentheses for you. All these arrows, right? That's what this became. Okay, still cleaning up. I now get 1/4 times 1 plus 2 cosine 2 theta plus, I am now going to take this fraction and split it into 2. I have 2 terms over the same denominator. So this will become 1/2 plus cosine 4 theta over 2. That's it. That's all I did, was I split into 2 fractions. Purely algebraic. Now, I will distribute the 1/4, and we're getting there. I get 1/4 plus 1/2 cosine 2 theta plus 1/8 plus 1/8 cosine 4 theta. So all I did was take this 1/4, distribute here, 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 and there. That's it. Nothing crazy. And now, all I want to do to finish this up is add this 1/4 and add that 1/8. 1/4 plus 1/8, 3/8, right? So we get 3/8 plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. There it is, kids. This is what cosine to the 4th theta equals. Is that another formula? I think so. There you go. Whew, buddy. All right. No. There we go. All right. So that is a formula for cosine 4 theta. So now let's do it for sine to the 4th theta. We want to prove that sine to the 4th theta is equal to 3/8 minus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. So we're going to work this one exactly like we worked the last one, okay? So let's do it. Do I get a whole page for this one? I sure do. All right, we'll work it as we go. All right. So sine 4 theta, we will make into sine squared theta times sine squared theta. Oh, and by the way, when you now look at this formula, are there any powers greater than 1? No. That cosine to the 2 theta is to the power of 1. That cosine 4 theta is to the power of 1. And that was our goal, to write this formula with no powers greater than 1. Okay. So now breaking this down. Okay. So sine squared theta times sine squared theta, we're going to do the same thing that we did above. Use our new double angle substitution. Sine squared is now 1 minus cosine 2 theta over 2. That's what we're plugging in for sine squared. Right, 1 minus cosine 2 theta, yes, okay. Okay, so this becomes 1 minus cosine 2 theta over 2 times the same, 1 minus cosine 2 theta over 2. Rewrite it. 1 minus cosine 2 theta times 1 minus cosine 2 theta all over 4. FOIL it. 1 minus, and I'll sum this up a bit. You'll get 2 cosine 2 theta plus cosine squared 2 theta over 4. Now, once again, I'm going to do that substitution trick that I did above, so you get to see it again. Remember, cosine squared theta is 1 plus cosine 2 theta over 2. Okay, so here's where we do that substitution trick again, right? So we are going to let this become x, which means, again, we're going to use this formula, but now I have cosine squared x equal to 1 plus cosine 2 times x. All right, all over 2. And then cosine squared of my x. Oh yeah, sorry, I'm bringing it in now, right? So cosine squared, my x value is 2 theta, which means that that goes in for x. So 1 plus cosine of 2 times 2 theta. Over 2. So cosine squared 2 theta is again 1 plus cosine 4 theta over 2. Same exact thing that I did above. So then that goes back in. So many colors. Okay, and just like the last one, I'm going to pull the 1/4 out. So I get 1/4 times 1 minus 2 cosine 2 theta plus what this becomes, which is 1 plus cosine 4 theta over 2. So once again, all of this became that. Okay, now the rest is cleanup. We got the powers down to 1, split that fraction into 2, then distribute the 1/4. 1/4 times 1 minus 2 cosine 2 theta plus 1/2 plus 1/2 cosine 4 theta. Now I distribute that 1/4. 1/4 minus 1/2 cosine 2 theta plus 1/8 plus 1/8 cosine 4 theta. Once again, combine those two, and we're done. Three eighths minus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. And this is the formula for sine to the 4th theta. Eef. Not bad. There you go. Same exact process as above. And by the way, did we prove it? 3/8 minus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. That checks out to me. Check. Oh boy. All right. Doing it. All right. I'm going to do these last two problems and then stop recording because right now it's probably a formula overload for you right now. So let me solve these two because after these two, we get into more formulas, half-angle formulas. So we'll make this 2 parts for us just to ease our brains because they're probably melting right now. Okay. All right. So solve a trig equation using identities. Okay. So it's telling us what to do. Use identities. And we are given sine theta cosine theta equal to negative 1/2. Well, we didn't make a formula for sine theta cosine theta. We made a formula for two sine theta cosine theta. So our goal is to change this into that. Well, that is the beauty of having an equation. Look at the right side of our equation. The right side of our equation is equal to negative 1/2. And since this is an equation, you can manipulate it however you want. So what I'm going to do here, I will rewrite it first. Hang on. So we have sine theta cosine theta equal to negative 1/2. So to get a 2 over to the left side, all we have to do is multiply by 2. Multiply both sides by 2. And we get 2 sine theta cosine theta equal to negative 1. And now, by identities, 2 sine theta cosine theta is sine 2 theta. So we bring that in. This becomes sine 2 theta equal to negative 1. Okay. And now, to solve for theta, we can apply the actual inverse, right? We can apply the inverse. All right. So yeah, we'll do that. Okay. So for sine 2 theta, I'm going to say, so if I apply the inverse to both sides, I'm trying to see what's a better method. Apply the inverse, but if I apply the inverse, here's the only catch. We have to stay between 0 and 2 pi. So when I say there's a catch, let's apply the inverse and see what happens.
I would say 2 theta equal to the inverse sine of -1. But remember, this inverse restrictions, this can only happen on -pi/2 to pi/2. And the restrictions we're given above is we must stay on the actual unit circle, 0 to 2 pi. So if you can make that connection, you're fine. If you can't, then we can't use the inverse. And just like I said, I'll elaborate on it. All right. Where on -pi/2 to pi/2 is sine -1. So there's -pi/2 and pi/2. There's 0. This means that sine can only be -1 at -pi/2. Because at this value, you're at 0, -1. Well, -pi/2 is under 0 to 2 pi. So if you can make the connection, if you put this back in the unit circle, this means that the equivalent angle is 3 pi/2. Okay. Which means if we roll with that, we get 2 theta equal to 3 pi/2. And all we have to do is divide by 2 or multiply by 1/2. Therefore, theta is 3 pi/4. 3 pi/4. Okay. The other way to handle this without inverses is, let's get rid of that unit circle. All right. So, option 2. Actually, don't start there. Start here. This is method 2. And I think this brings us to section 8.3. We say sine of 2 theta equals -1. Okay. Now, you have to see this as just theta and think of the unit circle. We say, where on the unit circle is sine equal to -1? And that only value of theta that sine can be equal to -1 at is 3 pi/2. But it wasn't theta, it was actually 2 theta. Which means to solve for theta, we would multiply by 1/2 and still get theta equals 3 pi/4. So method 2 is probably the best bet because you don't have to go to negative restrictions and have to bring it back to the unit circle. But if you understand that process, all good. Either way, you see we get the same exact answer. Okay, perfect. All right. All right, let's see. 3 pi, yes. Okay, cool. So here we go. Again, solving by identities. Let me clean that up because you can't even see it. Okay. Solve cosine 2 theta plus 6 sine squared theta equal to 4. And we want our values on the unit circle 0 to 2 pi. Okay, so since we have sine squared already, maybe we can put this all in terms of sine, which means that we have 3 formulas we can use for cosine 2 theta. I'll write them over here. Well, not all of them. I'm just going to use the one that I think I need. And we know that cosine 2 theta is also the same as 1 minus 2 sine squared theta. So that is what I am going to plug in for that cosine 2 theta. That's what's going in there. Okay. Of course, use what you want. Maybe you want this all in terms of cosine. That's fine as well. I can show that option right after this. But let's put this in terms of sine. So cosine 2 theta becomes 1 minus 2 sine squared theta plus 6 sine squared theta equal to 4. Then combine like terms, I get 1 plus 4 sine squared theta equal to 4. Move the 1 over, and I get 4 sine squared theta equal to 3. Divide by 4, sine squared theta equals 3/4. And then square root. Sine theta equals, very important, never ever to forget your what? Plus or minus. Square root 3/2. All right, now this one's definitely way easier than the one above it, because all we have to do is say, hey, on the unit circle, where is sine positive square root 3/2? And where is sine negative square root 3/2? And that is going to be, where is that going to be? That's going to be at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And there we go. All right. So that was putting it all in terms of sine. What if you wanted to put it all in terms of cosine? Well, then we would bring in another identity. We would say also cosine 2 theta is 2 cosine squared theta minus 1. Okay. Let me just double check that, because I have 20,000 formulas going through my head. Cosine 2 theta is 2 cosine squared minus 1, right there. 2 cosine squared minus 1. Okay. So again, method 2. I'll rewrite it, cosine 2 theta plus 6 sine squared theta equal to 4. This one's going to involve 2 identities. First identity is changing cosine 2 theta into 2 cosine squared theta minus 1. And the next identity is changing sine squared into 1 minus cosine squared theta equal to 4. Then I get 2 cosine squared theta minus 1 plus 6 minus 6 cosine squared theta equal to 4. Combine like terms, I get negative 4 cosine squared theta plus, what's that, 5 equal to 4. All right. And then subtract the 5. I get negative 4 cosine squared theta equal to negative 1. Divide the negative 4, and I get cosine squared equals 1/4. Then square root, I get cosine theta equals, don't forget your plus or minus 1/2. And now we ask ourselves, where on the unit circle is cosine positive 1/2 and is cosine negative 1/2? And guess what? It's the same values of theta. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. There you go. No matter what identities we use, the first one I put it all in terms of sine, the second one I put it all in terms of cosine. No matter what, we get the same values. Okay, I will stop it there because that's enough formulas for today.